Hi, my name is Samuel Taggart, and today I'm going to give you guys a presentation on choosing a framework. The point of this presentation is to help you pick through all the different framework possibilities that are out there and find one that meets your needs. So a little bit about me. I am the owner of System Automation Solutions. We are a small consulting company in Golden, Colorado. I'm a CLA. I've been doing LabVIEW for 10 years. I previously worked at Westinghouse Nuclear, and I've taught a little bit at Colorado School of Mines. I really enjoy teaching and mentoring people, and so that's why I'm giving this presentation. So the agenda for today's presentation. We're going to start off with talking about what is a framework. Then we're going to talk about how to evaluate and compare different frameworks. We're going to develop a list of criteria that we're going to look at. And then we're going to talk a little bit about the actor framework. That's what AF stands for. And then we're going to talk about the DQMH, which is the Delacor Queued Message Handler. And then we're going to take those two frameworks and we're going to look at them in terms of the criteria that we developed. I just picked those two because they happen to be two of the most popular. There are plenty of other frameworks out there I could have chosen. So what is a framework? A framework is a software abstraction layer, and it provides a method for solving a generic set of problems. And if we look at our picture of the building over here, right? The method of building a skyscraper is you put all these steel beams together and you connect them, and that's our method. And framework gives you the ability to customize the framework elements to solve a specific problem. So you can take this theory of building a skyscraper out of all these steel beams, and you can make many different types of skyscrapers. You can make an office building, you could make a high-rise apartment building, you can make a mixed-use building, commercial building, you can do all kinds of different things. You can customize it, but they're all built on the same framework of steel beams connected together. And a framework gives you a set of tooling and APIs to bring it all together. So in the case of our steel building here, the tooling might be cranes and welders and riveters and all that stuff that puts all the pieces together, and then the end user kind of customizes it. Three important things to understand about a framework. It's got three things that differentiate from normal software libraries. Number one is a big one, and it takes a little bit to wrap your head around, but it's called inversion of control. So what this means is that normally in your code, if you had a DAC driver, your code would run and you would provide the general looping structure of your code. And then at certain points it would call the DAC driver and get some data from the DAC driver, and then it would display it and go about its way. With the framework runs and controls the looping and the general structure of the code. And it calls your code that you provide to extend the framework. So for example, it might be when you receive a specific message, then you provide a piece of code that executes when that framework piece receives a specific message. And that's to allow you to extend the framework. So that's the extensibility part, is that you can change the way it responds to different messages. You provide the code that executes in different cases. I think of it almost as like an event structure, right? The event structure provides the control, right? And you provide what happens in each of those cases. The framework's kind of similar. But there are some things you can't change. So there's non-modifiable framework elements. There's certain things that are there that have to be there in order to make some of the guarantees that a framework makes, and we're going to talk about that in a minute. All right, so you might have heard the term design pattern get thrown around, and we talk about that a lot in some of the classes. A framework is not a design pattern. A framework is more like a collection of design patterns. Design pattern is more like an algorithm. So like a design pattern might be a specific way of putting like Legos together to make a corner, right? And then the framework might be how you put all those corners and all those pieces together to make a big skyscraper like the one on the right that is made out of Legos. So in conclusion, right, the framework provides a specific method of developing code, which is really nice because if I look at somebody's code that was using a specific framework and I go to another project and it uses the same framework, it's going to look similar. It provides a variety of tools, support code, APIs, Application Programming Interface, in case anybody doesn't know that. So it's how the rest of the code interacts and how you, the developer, interact with it. Templates and other things to aid you in the development process. It provides flow control for program execution, right? So it controls the looping in the structure. Provides guarantees for certain things. Error handling, right? You want to make sure that all errors get handled. Message delivery. Some may or may not make promises on that. You have a framework that says you will get every single message that's sent, and you might have a different framework that says I only care about the latest value. I don't care if it's changed 10 times since the last time I read it. I just care about what it is right now. And that's one of the things that we'll look at when we look at different frameworks. Shutdown process, right? If you send a stop message, is it guaranteed to get there and will things shut down correctly? Can you control the order in which things shut down? Reference management is a big one. Making sure that references stay alive for the correct amount of time and get cleaned up at the end. You, the developer, you provide code that is called by the framework, remember that inversion of control, in order to customize the program for your specific application. So why should you use a framework, right? Well, it gives you a starting point, right? So you're not starting with a blank diagram, you've got some structure already to your code. You write less code, because a lot of it's already written by the framework. And a lot of the framework tasks can be scripted. So creating new messages, new modules, a lot of that is very repetitive and it's very similar, so you can script it. And a lot of the frameworks come with tools to help you do that. It provides structure to your code, and it helps you to standardize. If everybody in your group is using the same framework, then you can move from one project to the other very easily. Another thing is support. If you make your own framework and then you go to NI for help and you're like, I don't know why this is doing what it's doing, they might not understand what's going on. If you go with one of these frameworks and they're familiar with the framework, it's easier for them to help you. You can avoid some common pitfalls. A lot of that has to do with the guarantees that I already mentioned. And you're using a proven solution, right? People have used these frameworks before and been very successful. So you might be thinking, well, I'm a great programmer. I know what I'm doing. Why can't I just make my own? Well, the first thing I would say is don't reinvent the wheel. If it already exists and it meets your needs, you're just wasting resources. The other major reason is you avoid a lot of anti-patterns and common pitfalls. So anti-patterns are things that maybe seem like a good idea at first, and you go down the road and then you realize that there's some kind of dead end or some reason that it just won't work. So a lot of these frameworks have been around for a while, so they've thought of all these things and these common pitfalls, and they've already addressed them. If you feel like I just want to make my own framework, I would say carefully consider why you want to build your own. And if you can find an existing framework that does most of what you want to do, but you just want to tweak a few things, I would say that is a much better way to go, because then you can utilize a lot of the stuff that's already written and you're not duplicating effort as much. All right, so the next part of the presentation is developing a set of criteria for evaluating and comparing different frameworks. So just because you have a really good hammer doesn't make everything a nail. Right? You learned about the latest and greatest framework, and it's awesome, but it's synchronous, and you need something that happens asynchronously. It's probably not the right choice. So some of the questions that you need to ask yourself when you're talking about general paradigm is, do you need something that's single-threaded or multi-threaded? Do you need something that's synchronous or asynchronous, right? You got a bunch of stuff going on that has to happen A, B, C, D, and repeats over and over again? Or do you have 5 different things that are going on at once and they kind of interact a little bit, but they're all kind of doing their own thing? And then another question is, how is data moved around? Are you sending messages where you expect that the receiver is going to receive every single one? Are you using tags where perhaps the receiver only really cares about the latest value, and it can be lossy because you don't really care. You just care about what state it's in right now. Or maybe you're streaming and you got a ton of data and you want to capture these big, huge waveforms, right? Each one of those has some different trade-offs, and it's going to result in a different framework. Other things to think about, broadcast or addressed messages, right? Are you sending a message to a specific part of your system, or are you just broadcasting, telling the whole world, hey, I'm here, or this happened? You might want some sort of publish or subscribe algorithm. And two big things that I don't deal with a lot, but if you do, it's very important, and that would be test stand. So whatever framework you want to use, will it integrate with test stand? And the other one is RT and FPGA, will it integrate with that? If you use those could be really big and really important things to consider. Okay, so the next item is power, right? I'm sure at least some of the people out there have seen the Tim the Toolman Taylor show from like the 90s, right? Where he's grunting and stuff, and he's always, putting bigger motors and stuff because he wants more power. It usually doesn't turn out too well for him. So in this case, we're talking about how complex of a problem are you able to solve, right? So in general, more power is better, but it needs to be appropriate to the problem, right? You've got the Lamborghini or Ferrari or whatever the fancy red car on the left is. Obviously much more powerful, obviously much faster. Probably doesn't handle as well, and if you're a 16-year-old kid, you probably can't handle that. So a Volkswagen, giving your 16-year-old Volkswagen to drive to school is probably the better choice, even though it's not as powerful. So the next item on our list is complexity, right? Which one of these two systems would you like to debug? Right? The simple old mousetrap on the left, or this Rube Goldberg contraption on the right? It would probably take me 5 minutes to figure out what's supposed to happen, let alone to figure out what's going wrong and what's not happening. Another thing to think about is the learning curve. If you don't ski or snowboard, you might not get this analogy, but I've done both, and anybody who has done both will tell you that they have completely different learning curves. You can put on a pair of skis and start at the top of the hill, and you very likely might make it to the bottom of the hill without falling down. You get on a snowboard and you get to the top of the hill, you'll go 3 feet and fall over. And you will repeat that the entire way down the hill. But then come back like 2 weeks later, and the snowboard all of a sudden has figured it out and is flying past the skier. Right? So they got different learning curves. So the question is, do you need to get up and running really quickly, or do you have time and energy and you're willing to invest in something that might pay off more long term? All right, so the next item on our list is competency. So you got to evaluate your own competency. Hopefully you're pretty good at that and you're self-aware enough. Your team, you should have a good idea of what they're capable of. The one that people often don't think about is the person who's maintaining the software. Right? Are you turning this over to a customer, right? Internal or external? Or who's going to take care of this? Maybe the person coming after you, right? If you're working there and you know that, I'm only going to be here another couple months and then I'm leaving to go do something else, who's going to come along and take over when you're done? And some things to think about, are they familiar with user events, object-oriented programming, queues and notifiers, act-oriented design, right? That's going to influence what type of framework you're going to be able to pick. All right, tooling. Good tooling is like oil. It just makes things run smoother. So if you have to remove a single bolt, a crescent wrench works just fine. If you got to remove 100, having the air gun is way nicer. So the question is, all those repetitive tasks that you have to do in a framework, like constantly creating new modules and new messages, which tool do you have to do that? Do they provide the air gun or do they provide the crescent wrench? It's going to make a big difference in how productive you are. The last one we're going to talk about is debugging and support. So I have a couple XKCD comics here. The one on the right, somebody put in an issue and they came up with a workaround for them. Well, if you wait long enough, eventually that will go away and it'll no longer be a problem, right? And then there's the one in the center is about tools that need manuals and don't. Right? So is it well documented? Do you need a manual? Does it have an extensive manual? Is there somebody you can call for help? Is there a forum that you can post on? If they provide support, are they actually responsive? If you put an issue, will they help you fix the issue or find a workaround? Are they continuing development on it? Is it something where they're going to push bug fixes, or is it something where they've just washed their hands and said, there it is, go use it? And is it open, right? Do they let you look into the VIs and so that you can troubleshoot it yourself? Let's see, what else do I want to cover here? Oh, long-term thinking, right? 10 years from now, 5 years from now, will the company that created this framework still even be there? And will they still take it seriously and are still going to support it? All right, so now we're going to start talking about the actor framework and the DQMH. And they're both very complex. We're not going to cover everything. We're going to cover the tip of the iceberg. So there's a whole lot more that you're not going to see. If you want more information, there's a slide at the end that has a couple links. And if you download the presentation, there's a slide at the very beginning that I didn't show that has a couple links as well. All right, so first we'll do the actor framework. And there's a little bit of theory that has to be understood before we get into this. What is an actor? What do I mean when I say actor? Each actor is its own parallel thread, and it has its own state data. And it's autonomous. It has a caller, but it kind of makes its own decisions. And the caller can request that it goes and does stuff, but ultimately the actor is in charge. It can say, well, I'm in a state where I can't really do what you want me to do. And the only way to communicate with an actor is through messages. So you send it a message, and it sends you back a message if it wants. The messaging is asynchronous, so it's not like you go call the DAC actor and say, all right, go get some data, and I'm just going to sit here and wait, and eventually you'll give me my data back, and then I'll move on. You send the DAC actor a message, and then you go about doing your thing, and eventually the DAC actor, when it has data, will send you a thing that says, hey, I have data. Or maybe it sends you an error and says, I can't do that. I kind of think of it as like a corporation, right? Like you've got people working under you, and you give somebody a task, and you send them away, and they only come back when they're done or if they have a problem. And you're not sitting there waiting for them to come back. Very important topic in actor framework design is the actor tree. So you have this root actor, and it owns two nested actors. So the actors underneath are going to call that nested actor. So actor A and actor B are nested actors of the root actor. And it can go further, and you can have actor A1 or A2. And the root actor just knows about actor A and actor B, and if it wants to do something down here in actor A1, it has to tell actor A, and then actor A will send a message down to A1. That's the traditional way that this works. You can bypass the actor tree if you want, but the traditional way is an actor, for example, actor A, could only send messages to itself, to its caller, so it has its callers in queuer or mailbox. We'll talk about that in a minute. So it can send messages to the root actor, and it can send messages to actor A1 and A2. And that's all I'm going to say about that for the moment. So the most powerful part of actor framework comes from the fact that it is based on object-oriented programming. So what you see in front of you, this is the actor core.vi. This is the main VI that runs when an actor runs. And I said that all actors have state. You can see in the shift register at the bottom that the actor itself, that object, is being passed around. And this send to self and queuer is like a mailbox. Right? It's basically a queue. I think of it like a mailbox. So the first thing that happens in the while loop is we check to see if there's a message, and we wait for a message. We get a message, and then inside the first error structure there, that's called do.vi, and it does something depending on what the message is. So in an old queued message handler, you'd have a case structure there, right? And the message would have some sort of identifier, either a string or an enum, that would do something different depending on what message it is. We've replaced that with dynamic dispatch. And then after we act on the message, and you notice the message has an actor in and an actor out, so it can act on the state. Then we have an error handler, and then that determines when we exit or not. And we stuff the actor, which has been modified now, back into the shift register, and we go around again. And at some point we exit, and then right before the actor out, there's a little VI with a stop sign there. That is the cleanup. It's called stop core, I believe. So you can override the error handling, you can override the stop core, and you provide the messages that provide what happens when the actor receives a specific message. But this is part of the framework, this VI. So there's two different ways to give your actor more abilities, more things to do. One way is to have a inheritance tree. So in this case, we have a timed loop actor, and here we're inside its actor core. It's calling the parent method. So where it says call parent method, imagine that all that code that we saw there was just sitting right on the block diagram. That's what's going on up there. And there's another loop in parallel with it, and it's just sending an update. So this is send update. So every however many milliseconds, it's going to send a message to itself. So it's going to pop it into the queue so it shows up here in our call parent, and it's going to do something. And then the level controller inherits from that. So the level controller automatically, when it calls its call parent, it's got the actor core call parent, the time loop call parent, and then whatever it adds to it if it decides to add something to it. So that's one way to give your actor more functionality, is to use inheritance. You can also do aggregation, right? So you can take, or composition. So you can take your actor, and if you remember actor tree, right, we had nested subactors. Here we have a cooler, right, which inherits from time loop and level controller, but it also adds some functionality because it adds a dual fan, a dual pump, and a water level. And it's launching all these as nested actors. So when it launches a nested actor, so anytime you launch an actor, whether it's a nested actor or a regular actor, you get back an enqueuer. And so you hold on to that, and that is what you use to talk to it. All right, time for a very quick demo. Oops. And slideshow. All right, so demo. Actor framework demo. So I've got a couple actors here that I made. First thing, to make an actor, new actor. Give it a name, select what it inherits from, and where you're going to store it on disk. So I created an actor called myActor, and it produces a LVLib file, and it produces an actor class. When you first create it, it doesn't have any methods underneath it, and this folder is empty. Right, so then you go here and you say, okay, well, I want to create a new VI from static dispatch template because I want to have a message that I can send to my actor, right? So the first step is to define what's going to happen when your actor gets the message. So I created a VI called show pop-up, and I set an input as a message. And you'll see that it takes the message and it shows a pop-up. And just to show you guys that it maintains state from one iteration to the next, I added an I32. So I went to my actor, to the private data, I added an I32. And I'm going to increment it every time and just add that. So I'm going to say this is message number 1, 2, 3, 4, and I'm going to display the message. All right, great. So now I know what's going to happen when I have my message, but how do I actually create the message and how do I actually send it? So creating the message, you click on your method and you click on create message, and it will script it and it will create a message. And it shows up under messages for this actor. So it's called show pop-up message. And it gives you a send VI, and you'll notice you need an enqueuer. So you need a mailbox. Think of the enqueuer as a mailbox, and you pass it the message that you're going to send. And all it really does is take your pop-up message, store what the data that you're going to send with the message, which is message, and it drops it in the queue. And then this do VI, it does some type checking and some stuff, and then here it calls, this is the VI that we made, the show pop-up. And this is what executes inside that actor core main loop that's going around. All right, so we've got an actor, we define what happens when we receive the message, and we've defined a message. Now, how do we actually get the actor running and send it the message? You need a launcher. So I've got this VI, and ignore this down here for the moment. We'll talk about that in a minute. But it's true now, so we're going to pass in my actor into this launch root actor. So launch root actor launches an actor, and it gives you the actor's enqueuer, which is its mailbox. And you can see here I have the while loop and I have a stop button. So when I want to stop, I'm going to send it a stop. And I have another button called show pop-up. And this is the VI. Where's show in project? Right, this is send show pop-up. So I'm going to run this. And if I type in hello world and click show pop-up, I get a pop-up. If I hit it again, I get a pop-up. This time it says message number 2, message number 3. So it's keeping track of how many messages it has. And then I stop it and it stops. All's well. And I talked about the great advantage of Actor Framework was being able to use inheritance. So I was able to right click and create another actor. And this time I selected inherit from my actor and I called it my actor with UI. Right? And it gave me an actor and these couple empty folders. And I decided I want to keep the pop-up, but instead of having the launcher send the message to tell it what to do, I want to see the front panel of my actor, and I want to be able to click on the front panel of my actor and send the message to myself. So I have this actor core, right, which is running, and here's the call parent node, and I added another loop, and I added a structure here, a event structure, right? So when I press stop, I want it to stop. When I press show pop-up, it's showing pop-up, and this is send to self enqueuer, right? So it's sending it to itself. And then I added a stop event so that when the main loop stops, it will send an event to this and tell this to stop. It's a very common technique. If you take the Actor Framework class, you'll learn all about it. And I added front panel open and close to pop the panel up and not. So now, if I use the same launch actor and I change this to false, notice I didn't change any other code. All this is still the same. I pass in my with UI actor, and now I'm going to click on run, and I'll get the GUI from the launcher. Right, this is my launch. This is the GUI I had here, and it still works. And I can send a message. Or I can use my actors front panel and I can send it a message. And you can see that was number 2. And if I can send this again, this is number 3. And I can click stop and it'll stop. But my launcher didn't stop, right? Because it doesn't know that the actor stopped. Now when I hit stop, I got an error. Because when the actor died, its queue died. So sent it stop, but the queue had already expired, so it just threw an error and exited. So there's your very basic Actor Framework demo. If you're wondering how to send messages back, that's a little more tricky. You need to investigate abstract messaging, and that's beyond the scope of this, but look in the class or look on the online forums and you'll find more information about that. All right, so let's close that. Now, I think I got a few slides here first. All right, so Delacor Queued Message Handler, the DQMH. I think of it as a queued message handler on steroids. If you look at it, it looks a lot like the NI Queued Message Handler. If you watch Fabiola's presentation, there's a link at the very end. She explains that she started with the NI Queued Message Handler and then improved it, so it's not surprising. So when the module starts, we have this init over here and create some user events. So basically the way this whole thing works is an event happens, the top event loop catches it, and when it catches an event, it drops something in the queue, which then is read by the bottom loop where our state data is, and then it decides what to do and does it. And so everything that comes in from the outside world comes in through an event, and everything that goes out to the outside world is broadcast as an event. So we got this top loop, right? But either a button press or one of these events that it's registered for, and we'll talk about those in a minute, occurs, and we drop it in the queue, and it comes down here. best part about the DQMH is that you get a test harness. So when you create a module, it automatically creates a test harness. And not only does it create the test harness, but every time you add a new message, in or out, event actually. But anytime you add a new event, in or out, this gets updated with the new event. So you can see it has buttons to press for test, do something else, test, do something else, and wait for reply. And you can see there's logging what's going on. So that's really awesome. All right, so let's do a quick demo of the DQMH. All right, so I went to new project from the getting started window and from template, and there's a DQMH template. And it creates this. I haven't touched anything. So you've got the modules, you've got the testers, you got some documentation. And just like in the actor framework, we had like an overlying application that called our actor, right? We had our launcher that launched our actor. Here we have an application that uses our modules. So there are two types of modules. There's a singleton module and a clonable module. Singleton only lets you launch one, and if you try to launch it again, it just tells you it's already launched, and then any command you send all go to the same module. Clonable lets you launch as many as you want. Every time you call the launch or start, it starts a new one, and it gives you back a number. And then every time you send a message, you give the message that number, and then it goes to that particular one. Or I think you can put in -1 and it'll broadcast it to all your clonables of that particular type. All the clones of that module. And the APIs for both are the same, so we're just going to stick with the singleton for now. So first thing you notice, there's a bunch of folders. Everything's private except for this public API. So to the rest of your program, the only thing it knows about is this public API. These are just type defs. The requests, these are all the things that you can request that it does. So one of the keys to the DQMH is you have request events and broadcast events. So request events go into the module, and the module responds to them and does something. And broadcast events occur when something happens to the module. So if it's monitoring some hardware and there's a state change that says, oh, the state changed, right? Or if you tell it to do something, it'll go do it, and then when it's done, it says, oh, I'm done with this calculation or whatever it is. So we got do something else. And then there's a couple that are built in. So show panel, hide panel, stop module, get module execution status, show diagram. Those are all built in. They come with the framework. You got a start module that will start the module, and it gives you back all the broadcast events that it can generate. And there's some synchronization here. We'll show you how that works in a minute. And then at any point in time, you can pull off the broadcast events so you can register for them. And everything's events behind the scenes. So this do something, if you take a closer look at it, it is just taking your data, putting it into a type def, and it's firing off an event. And the main is registered for that event. So the main, this is the main, which is the VI that you saw earlier on the screen with the two main loops. This is basically the equivalent of your actor core. The one nice thing about it is that you can do a UI right here because you've got an event loop already at the top. You don't have to have a child class that adds the event loop like I did for the actor framework. So that's quite nice. The upside to doing the actor framework way is you can decide to have the UI or not. Here you kind of got the UI with, if you build the UI together, you either have, you've got the UI with you all the time, even when you're not showing it. So I don't know if that's a big deal. Depends on your style, I guess, and what you're looking for. So we went over all that. Let's look at the application, then we'll look at the testers. So main. So she's got a little bit of a state machine. We're initialize panel. So wait for event. Right. So it goes to a couple initialization states, and then it gets here and it says wait for event. And you'll notice here, it's collecting the broadcast events. So it's registered for the broadcast events from the singleton module and the clonable module, and they're registered for, so they show up in here. Right here. See my clonable module, my singleton module, did init. There's some other events. Those are like built-in events. And so here we're calling the singleton module start, and we're waiting for the synchronization. This is to make sure that you register for the user events before it starts generating. And then if we look at show my singleton module, here it's show panel. So it's sending the show panel event to the singleton module, and then it's updating the status, and it's going to come back around and wait for the next event to happen. So let's just run this. Start singleton module. If I click start singleton module again, it doesn't launch another one, right? And I can do something, right? And it registered that I did something. Okay, great. I'll stop that one here. If I start the clonable, I start it, got some random number assigned to it. Here, oh, I start another one. Oh, I start another one. So I've got a bunch of them. And I can send something to one or all of them. So if I stop one, I just stop that one that I selected, or I can stop them all. But the best part about DQMH are these testers. So let's test my singleton module. So here's a tester, and see, it registers for the events, and then it waits for you to do something. So if you start module, right, starts the module, registers for the events. And test do something, you test do something, you press it, and you tell it to go do something. And then these are the events that come back. So when it updates its status, you get the status and it adds it to the log. So let's just run this, start module, show the panel, hide the panel, show block diagram, which is really nice because very hard to get to the block diagram on an actor, by the way. Test do something, then test do something else, and you can show the panel, and you see, I got to do something else. And you can simulate errors, and you can stop it. And then you can exit the tester. One thing we will look at before we go, I don't think I showed you all the tools for creating new messages. So all the AF tools are right-click, so they're context sensitive. The DQMH tools are all right here under Delacor DQMH. So you can add a new module, give it a name, pick the type. You can actually create templates and throw them in a directory, and they'll show up here. So we'll start with one of those. So that's kind of interesting. Not quite inheritance, but. And let's see. So you can also create a new event, whether it's a broadcast event or a request event. You click here. You pick the module. Pick whether you broadcast and reply. You're supposed to give it a name, give it a description. Click OK, and it'll create it for you. Actually, let's do that in a minute. And then you can remove, rename module or event. Validate is if you've made some changes to the module and you want to make sure that all the scripting tools still work. But let's add a new event. All right, so I've got the singleton open here, and I'm going to say my singleton request, my new request, a new request. And I'm going to pass it a Boolean just because I can. Okay, so I click OK, and it's going to generate my new request. The really nice thing about the DQMH is not only did it create my event, so it added my event to the events, not this event, but it was a request event, so but it registered for it. So my singleton, my new request, took the data, bottled it up, sent it down here. So it gets rid of a lot of the problems with the string invariant come from not having the same type of data where you put it into the variant, where you take it out. This scripts it, so it already has it, so that's really cool. It gives you these little bookmarks. So if you've not used the bookmark editor, there is a view bookmarks manager. So you can see all the code needed. So this will tell you where you need to put code in. But yes, so right here is when you get your request, what do you do with it? And let's see. The nice thing is it should have added it. So here it did. It added a test my new request. So it didn't give me a button or anything here yet, but I can add a button. Copy one of these. We'll give it a new name. Test my new request. And you can put a boolean here. And now I've got a way to test that my new request does whatever it's supposed to do. So that's really nice. And chances are if it works here, it's going to work in my program because this is using the exact same API that any other module my program would be using to interact with my particular module. So that's really nice and really powerful. It's really hard to create something like this for the Actor framework. It's a lot of work. So Fabiola and the people at Delacor put a lot of effort and work into doing this tester. And they give it all away for free too. So, all right, I'm going to close all this out, and then we'll get back to the meat of the presentation, which is our analysis. All right, so that was our demonstration. So we looked at what is a framework, what kind of criteria are we looking at when we compare them. Then we took a brief look at the Actor framework and the DQMH. Again, just tip of the iceberg. There's a whole lot more to those. So now we're going to compare them. Let me start by saying they're both very good frameworks. You can get a lot of mileage out of either one. And you should definitely look at both of them. And you shouldn't necessarily limit to just those two either. There are plenty of other ones, and there's a list at the end. When I compare and contrast these, it's not to say one's better than the other. It's just to give you an idea of what I'm looking at when I look at the two of them and what I see as some of the differences. And it's not an endorsement. You know, you could make the case for either one depending on what you're trying to do. So, all right. So just a quick review. The things that we talked about for comparing were the paradigm, the general, what type of problem does it solve? How powerful is it? How far can you push it? Can you know, what's the limit on how complex of a problem you can solve with it? How complex is the framework itself? You know, is there a lot going on? Is it really simple? What's the learning curve? How competent do you have to be in order to use it? The tooling it provides, the debugging that's available, and support. All right, so the general paradigm for both is actually pretty similar, right? Each actor is a queued message handler, right? The DQMH, it's in the name, queued message handler. Both have a very defined way for interacting with it, right? In the actor framework, you send and receive messages. In the DQMH, you send and receive events. They're both asynchronous. DQMH does have a send response and wait for reply, but in both cases, they're generally asynchronous. The interaction is a little bit different in the AF, at least by default, it's hierarchical, right? So the actor is sending messages to itself. things above it or below it in the tree, but that's it. It's not going across to a sibling in the tree. DQMH events are not hierarchical, so anything can message anything in your system if it can get access to the event ref, or if it can drop one of those requests to do something. The nice thing about that is that the DQMH, since it's all events, it plays well with other parts of your program. The requests, you can drop them anywhere. And the register, anywhere you register for events, you can register for the events. So it plays really well with others. And I know Fabiola put a lot of effort into making sure it works really well with test stand. Actor Framework can work with test stand. If you take the class, they'll show you how to do that, but it requires a lot of work. One of the bigger, I don't want to say problems, but one issue with Actor Framework is it's contagious. Actors are contagious because the way you send and receive messages, it's always messages, and receiving data from an actor, back from an actor, it's kind of awkward if you're not an actor. Another thing in the paradigm is that in the actor framework, there's no concept of singletons. Every time you launch an actor, you launch a new actor. The DQMH has singleton modules and clonables, so it makes a very big distinction there. In the actor framework, I haven't really found that to be a problem, but potentially it could be. All right, power. Right? The actor framework is definitely the Lamborghini. It is way more powerful because you've got two different ways that you can extend it. You can take an existing actor and you can make a child of it and add some specific functionality. And in that child, not only can you use inheritance and dynamic dispatch overriding, but you can also add all new actors. You can add a whole new branch to the actor tree, and that's really powerful. DQMH, right? There's no inheritance concept, and there's no owning concept. There's not like this module owns these other modules, which is actually, I think, a little bit of a downfall, because in the actor framework, I can have a hardware manager, and I can have like different DAC instruments and stuff underneath that. And the rest of my program can't directly call to any of the DAC stuff. It has to go through the hardware manager. In the DQMH, it's kind of hard to set that up if they're all modules. You kind of have to put them all into one module or something. I don't know, maybe Fabiola has a design for that. If you're interested in that, talk to her, and I'm sure she can help you out with something. The AF actor framework, because of its inheritance, really encourages reusability. The DQMH, a little bit less reusable. Still completely reusable, but you can't do that inheritance thing where like, I want to use this, but I just want to change one little thing. One thing I found is that the DQMH, one issue where I think the actor framework really shines is if I have a bunch of modules that all, say they're all UI elements, and they all get inserted into subpanels, right? In the actor framework, I can have one class that says actor that has subpanel, and it handles loading the stuff into the subpanel. And then I make my new actors, and they just inherit from that, and they automatically get it. In the DQMH, I've got to create a module that does that, and then use that as a template, and when I create all the other modules, I create them from that template. The problem comes in that if I then find an error, I want to change the way I do that. In the actor framework, I can just change the parent class, and all the children immediately get those changes. In the DQMH, if I've created this template module and everything is created from this template module, it's a copy of the original module. So then I have to go find everywhere that I was using that code and change it. There are patterns to deal with that, but that's just one pet peeve I have. But definitely if you're good with object-oriented stuff, you can avoid that. Although if you know object-oriented, you might not be using the DQMH. Complexity is the next one. In the actor framework, you got a lot going on. You got tons of classes, and you just got to keep track of which classes do what. And you've got different messaging paradigms, which we'll talk about a little bit maybe. And it's really hard to figure out what messages a particular actor can receive, because all you see here is I see indexer. Okay, well, indexer in its library has these abstract messages and these messages. But I can send to an indexer any message that its parent can send, and I can receive from it any message that its parent can send out. But from the project tree, I can't tell where its parents are. What, does it have any parents? I don't know. Right? I've got to go to the class hierarchy and look it up, and then I got to look at each of those and see what messages are in there. And it's kind of a pain. In contrast here, the singleton module, the public API is really clear. It's just right here. I've got my requests and I got a couple overhead things of starting and synchronizing and getting my event registration. So way simpler to interact with and deal with. To show you more of the complexity of the actor framework, this is the class inheritance hierarchy for an actor framework project that I worked on. And so in the center here, this is just a blown up section of like, I think it's this over here. But here's my actor, and then I have a bunch that have a subpanel. I mentioned having subpanel UIs, and there's a whole bunch here. And I've got some that have a subpanel and self-update. And here I have SI pump. And I've got two different types of pumps. And this whole abomination over here on the right, well, this whole level here this is message, and there's a whole bunch of messages, and then you can have layers of messages too. So it gets complicated really quick. But like, for example, this lift controller, right, when I was talking about messages, it can send and receive all the messages you can send and receive to the lift controller. You can also send it any message for self-update has subpanel, right? And it can any events or messages that either of these generate, the lift controller can also generate. So this isn't too bad, but you could imagine if it gets much deeper, it would get really hard to figure out, okay, I've got this actor, what messages can I send in, and what message it can send to me. All right, so complexity. Overall, actor framework, very complex. DQMH, much more straightforward. Also, the fact that it all kind of fits on one VI with the two loops is really nice for the DQMH. For the EF, you've got all these overrides that you have to sort through to figure out at what level of inheritance is this or that behavior happening. The actor framework has multiple messaging paradigms. I talked about how it's a little bit more difficult to send messages up the tree. So it's got loosely coupled and zero coupled and highly coupled messaging. And part of the reason for that is to encourage the reuse. So there's a whole theory behind that. If you take the actor framework class, I'll tell you all about it, or you can troll in the forums and find where they talk about that. DQMH is really straightforward. An event is either a request where you're asking the module to do something, or a broadcast. That's it. In the actor framework, messages are not type safe. You send a message, you need an enqueuer, but it doesn't care where that enqueuer came from. Enqueuer is a mailbox, so you can easily send your paycheck to the wrong mailbox, right? And somebody else will go cash it or whatever, right? So you gotta be very careful about where you're sending messages. DQMH, the events, because of the way they're scripted and the way they're handled by LabVIEW, they're type safe. Everything's type deft. So it's really easy to add stuff to it too. If you have a message in the actor framework and you suddenly want to add some more data to it, it's a little bit more complicated. Actor framework, huge class hierarchy, mostly because of the messaging. And if you've ever worked with a large number of classes in LabVIEW, it can get complicated and it can really slow down your computer and cause all kinds of problems. DQMH, right, uses events, and a lot of the complexity of the events, you know, the registering and unregistering and cleaning up ref nums and all that is hidden by the scripting. Actor framework, I mentioned, it can be difficult to locate the message you want to send, particularly with large hierarchies. DQMH, finding event VIs in the project is really easy. So it's really easy. You click on the exact module you want, go to its public API, and you grab whichever send this or send that you want. So learning curve. Actor framework is definitely the snowboarding. It's complicated at first. It can take a long time to get up and running with it. And then eventually you kind of have this aha moment where you kind of get it, because it really requires a change in the way you think about the problem. And once you get that, then you can get up and running on a project pretty quickly. DQMH is really easy to get up and running, but at the top end, it's not quite as powerful as the actor framework, so it kind of plateaus. But it's plateaus at a really high level, so you can still do some really awesome stuff with the DQMH. I wouldn't necessarily let that stop you, but you know, once you reach that plateau, you'll know it, and you'll be like, okay, I should do this particular project in the actor framework. Competency. Actor framework, you must know OOP in order to be able to design a program to use the actor framework and lay out the architecture. Aristos Q, Stephen Mercer will tell you that OIF is great for beginners and all this, and he's a really smart guy and he's entitled to his opinion. Mine is, if you don't know OOP, you're going to be lost. But you know, you can have that discussion with him. But it's geared, the designing programs in the actor framework is geared towards CLA. Filling in some of the minor details, you might be able to get away with assigning to somebody who's not a CLA. The DQMH is specifically geared towards CLDs, CLADs, right? It does not use OOP. Actually, it kind of does under the hood in a few places, but you don't need to know anything about OOP in order to use it. Good old-fashioned queues is all you really need to know, and the event stuff is kind of handled by the scripting and kind of transparent to you, so you don't even really need to know about events. Actor framework, you got to know about queues and events, because if you've got helper loops in your actor core, you need to be able to use those to communicate. So actor framework tooling, you can see from the picture it looks kind of disjointed, and it is. It's all over the place. You might look at that as an advantage. It's all context sensitive, which is nice if you can remember what context you're in and not get confused. I would much rather have something like the DQMH, but once you get used to it, it's not that bad. The DQMH tooling, it's all in the tools menu in one spot, and instead of having a ton of different things you can do, it's got a handful of things, and you can figure it in the dialog box. So I like it quite a bit. So in terms of tooling, the actor framework and the DQMH both provide a template. They both include palette VIs. Actually, I don't think I showed you the DQMH palette VIs, but the tooling for the AF, context sensitive, DQMH is consolidated. They both have module creators. DQMH automatically creates a debugger, which is awesome. Actor framework, not so much, but they have a different way of debugging it, which we'll talk about. They both have things for creating messages or events. The actor framework message maker doesn't really allow for renaming or deleting, but it allows rescripting if the input's changed. If you add a new input, you can change that. DQMH has tools for renaming and deleting events and moving stuff around. All the event data is typedef. They do a really good job with it. All right, so debugging. Actor tree, if you adhere to it, makes tracing messages much easier, because you can kind of say, okay, well, this is coming from here. And, it's much simpler. DQMH, broadcast nature events, right? You broadcast an event. Okay, so you're tracing down what happens. You press a button. Okay, it sends any request to this particular module, and then it broadcasts an event. Okay, well, where is registered for that event, and what happens when I broadcast that event? I don't know. It's really hard to trace. Actor framework, execution trace, and you click the little light bulb, right, and you can follow all the wires. It's often not available due to reentrancy issues. DQMH, it's easily available, and you can easily show the block diagram. Actor framework, it's hard to find the correct clone, because every time it launches an actor core, it gets a clone number, and you got to figure out which one's which. The actor framework solution to debugging is to add desktop execution trace toolkit support, which is actually an extra add-on. I don't know if it actually ships with NI stuff or not anymore. But you can definitely look into that. And you throw a flag, and then it spews a whole bunch of DETT traces that every time an actor is created and who sent messages to who, and it can get overwhelming, but it's definitely a start. DQMH does not have that built in, although there's an API for it and you can add it. Support. Actor Framework is officially supported by NI. There's a AF community group, and they have an official training class. And the class is really nice. If you want to use the Actor Framework, I highly recommend it. DQMH is provided by Delacor, which is Fabiola de la Cueva. They have a community group on the NI forums page, and they have tons of videos, documentation, training materials, and a blog. So they do a really good job of documenting everything. And it should be noted that they did win the 2016 LabVIEW Tools Network Product of the Year. So obviously a lot of people think it's really great. So it's got a lot of things going for it. So which framework should you use for your project? Well, it depends on all the stuff that we just talked about. So final discussion and next steps. Here's some other things that you should look at. Top level baseline, Norm Kirchner wrote that. JKI state machine objects. Featherweight, which is Jack Dunaway. LabVIEW Messenger Library, Lapdog, which is DACLU or Darren Snyder. BiRef Active Object Framework, Message Pump. There's a couple other ones out there. All the definitions came from Wikipedia. If you want to know more about the DQMH, this is Fabiola's decision behind the design presentation. This shows where it came from. It explains it and what its goal is. It's really awesome. This is the original Actor Framework white paper. Explains some stuff. Some things have changed since then. A lot's gotten easier. If you're using the Actor Framework, do 2015 if you can. The process for launching and instantiating actors is much nicer. It's what I showed you now. Before, it was really clumsy and awkward. You definitely want to use 2015 with the Actor Framework if you can. All right, that's it. Thank you very much.